All right, we are continuing section 7.1, polar coordinates. All right. So last time we learned how to graph points in polar coordinates, and we talked about finding more than one representation of a point in polar. So we're going to do, and let's remind ourselves, any point in polar can be written as r, they say theta plus 2 pi. And I'm going to put 2 in pi, because really it's as many multiples as you want to add, okay? That's a different representation for a point in polar. Or we can say r theta is negative r pi minus theta. Okay, so if I want a representation that has r negative, I will use that. So with that in mind, example 2. Example 2. Let me make a little bit of an adjustment. There we go. Okay. So example 2 says given 4 pi over 6. So there's a point in polar. They say find 2 other polar coordinate representations. Find 2 other polar representations. Okay. So for A, they want r bigger than 0. So they want a different polar representation when r is bigger than 0. So again, all I have to do is I'm using this first one, and all I have to do is add 2 pi to the angle. So 4 pi over 6 will be the same thing as 4 pi over 6 plus 2 pi. Okay. Pi over 6 plus 2 pi. 2 pi is the same thing as 12 pi over 6. So 12 pi over 6 plus 1 pi over 6 makes 13 pi over 6. So there's another representation for the point 4 pi over 6 where r is positive. So this point and this point, if I plotted them on the polar coordinate system, would be the exact same point. Okay. And B says find another representation with r negative. So now I'm going to be using this one. R comma theta is negative r pi minus theta. So 4 pi over 6 is the same thing as negative 4. So again, r theta is negative r pi minus theta. So pi minus pi over 6. So you get negative 4, comma. Pi is the same thing as 6 pi over 6. 6 pi over 6 is the same thing as pi. So 6 pi over 6 minus 1 pi over 6 makes 5 pi over 6. So those would be 2 more representations of that point. And we can clearly see that one of those representations has r positive and one representation has r negative. So those are 2 additional representations of that given point. So we did what they asked us to do. So it's never hard to find different representations for points in polar, okay? Well, next we're going to talk about converting. Convert from polar to rectangular. And I'm going to say and vice versa. Convert, we're going to learn how to convert from polar to rectangular and vice versa. Okay? Well, we're going to need a few things. So we're going to need the following. X is r cosine theta. Y is r sine theta. Tangent of theta is y over x, and x squared plus y squared is equal to r squared. Those will be the things I use to convert from polar coordinates to rectangular coordinates and vice versa, because we talked about it. And for instance, this point right here, this point lives in the plane. The polar representation is 4, 13 power of 6, but it turns out that point can be represented in rectangular coordinates too, and we're going to learn how to do that right now. Okay? So, example 3. They want us to convert the polar coordinates into rectangular. Convert polar coordinates into rectangular coordinates. Okay? So A, they give us 4, 3 power over 2. So R is 4, and theta is 3 power over 2. R comma theta. So I want to convert that into polar. So I want to convert it into some x comma y. Well, again, I'm using these two right here. So x would be R cosine theta. In this case, R is 4. Cosine of theta, but theta is 3 power over 2. So that's 4. The cosine of 3 power over 2, you can either use your calculator or look at the unit circle. At 3 power over 2, the cosine is 0. That's 0. The y-coordinate is R sine theta. But again, R is 4 and theta is 3 power over 2. So 4 sine 3 power over 2. The sine of 3 power over 2, if you look at 270 degrees, the y-coordinate is -1, so you get -4. So it turns out that this is the same thing as 4. X-coordinate, well, I'm sorry. The x-coordinate turned out to be 0, and the y-coordinate turned out to be -4. So there's my rectangular representation of that point. There's my rectangular representation of the point 4, 3 power over 2. So if I plotted this on the polar axis, it would coincide with that point on the rectangular axis. Okay. B, same example, convert polar into rectangular. -2, -5 power over 6. So R is -2, theta is -5 pi over 6. So again, x is still R cosine theta. So R would be -2 cosine of -5 power over 6. Well, the cosine of a negative angle is negative cosine of the positive angle. That's one of those identities. If you remember, cosine of theta is, well, so this is an identity. Identity. Should be on your identity sheet. The cosine of a negative angle is the same thing as negative, no, it's the same thing as positive cosine of the positive angle. Cosine is an even function, so the cosine of a negative angle is the same thing as cosine of the positive angle. So when I take cosine of a -5 power over 6, this -2 is still there. Cosine of -5 power over 6, according to this, is just cosine of 5 power over 6. But if I look at my unit circle, okay, the cosine of 5 power over 6, okay, that's in the second quadrant. The x-coordinate would be square root of 3 over 2. The 2's cancel out and you get negative square root of 3. Okay, you get negative square root of 3. And they say positive. Oh, yeah. You're in the second coordinate. You're in the second quadrant, so that's a negative. 2 negatives make a positive. Sorry. The cosine of 5 power over 6 on your unit circle is negative. Square root of 3 over 2. Okay? So, y-coordinate would be R, -2, sine of -5 pi over 6. Now, we have these identities. Cosine of a negative angle is cosine of an angle, but the sine of a negative angle is negative sine of the positive angle. That's another one of those identities on your identity sheet. Sine of a negative angle is negative sine of the positive angle. So the -2 is still here, but the sine of a negative angle is negative sine of the positive angle. A negative times a negative makes a +2. 2 sine 5 pi over 6. That's 2 times. Sine of 5 pi over 6 is positive 1/2. So that's 1. So negative 2 comma negative 5 pi over 6 turns out to be square root of 3, 1. That would be the corresponding rectangular form for that point. All right, so pretty easy to convert from polar into rectangular. Pretty easy. Well, let's go the other direction. Let's convert from rectangular to polar. So example 4, convert from rectangular to polar. So in A, they give me -3, and they say they want me to do 2 things. They say give 2 representations, one with r greater than 0, one with r less than 0. So give 2 representations. One with r greater than 0, one with r less than 0. Okay, so let's start with r greater than 0. All right. So again, and I didn't give you the point. The point is -3 comma 3. The point is -3, 3. Yeah. So I've got a point in rectangle. So x is 3, and actually x is -3. Y is positive 3. That's what they gave me. All right. Well, if x and y, if I know x and y, I can use one of those formulas I gave you a minute ago. I said tangent of theta is y over x. So tangent of theta would be y, positive 3, over x, -3. So that's -1. If you take a look at your unit circle, the tangent will be -1 in the second quadrant. Okay, the tangent will be -1 in the second quadrant. So theta turns out to be 3 pi over 4. Theta turns out to be 3 pi over 4. Take a look at your unit circle. At 3 pi over 4, your x and y coordinate. The x coordinate is negative square root of 2 over 2. The y coordinate is positive square root of 2 over 2. Tangent is y over x, so you get a -1. So theta turns out to be 3 pi over 4. And again, I started out with rectangle. I'm looking for polar, so I'm trying to find r and theta. So I found theta. Now all I need is r. But r squared equals x squared plus y squared. But I know what x and y are. X is -3 squared. Y is positive 3 squared. -3 squared is 9. Positive 3 squared is 9. So r squared turns out to be 18. So to get r, I take the square root of both sides. Square root of 18. 18 is not a perfect square, but 18 is 9 times 2. Square root of 9 is 3. So a 3 can come out of that radical. You always have to take as much out from under the radical as you can. So I get that r is 3 square root of 2. So we're done. We needed r and theta. We found r is 3 square root of 2. We found theta is 3 pi over 4. So we just found out that -3 is equal to r, 3 square root of 2. Theta was 3 pi over 4. So there's our representation where r is positive. We started out with a point in rectangular coordinates, -3, 3. And we just found out that the polar representation for that point where r is positive, we're going to do another where r is negative, but the one where r is positive would be 3 square root of 2, 3 pi over 4. Let's do the part of the second representation when r is negative. So I want a second representation, but this time I want r to be negative. Okay? I want this r to be negative. Well, we just did that. We said that r comma theta is the same thing as -r pi minus theta. So I can apply that to this. I've got r theta, r and theta. R is 3 square root of 2. Theta is 3 pi over 4. So r theta coincides with -r pi minus theta. So I'll say negative 3 square root of 2. And then my angle, theta, is 3 pi over 4. So theta, pi minus 3 pi over 4. Okay, so that's negative 3 square root of 2. So pi is the same thing as 4 pi over 4 minus 3 pi over 4. So I get negative 3 square root of 2. 4 pi over 4 minus 3 pi over 4 is just pi over 4. So there's my representation where r is negative. Okay? And they got a negative pi over 4. How did that work? I made a mistake somewhere. So 3 comma, well, negative 3, 3. And I said 3 pi over 4. So what did we do wrong? R theta. So we got that one, that's the first one. R negative. Why doesn't that work? Pi minus that. 4. Okay. Oh, okay. Well, let's do it this way. Sorry about that. For r negative, right? For r negative, okay? We knew that tangent of theta was negative 1, right? Tangent of theta was negative 1, right? And if tangent of theta is negative 1, that happens in 2 quadrants. That's either the second quadrant or the fourth quadrant, because again, tangent is y over x. So tangent will be negative 1 in the second quadrant or the fourth quadrant, okay? And if it's a fourth quadrant angle, okay, if I think about this for a second, in the fourth quadrant, see, I'm looking for the point that coincides with negative 3 comma 3 in the fourth quadrant, okay? So if I think about it, again, we had just found out that for 3 pi over 4, theta 3 pi over 4, right? That's where tangent is negative 1. But also at negative pi over 4, right? Right here, the x-coordinate is square root of 2 over 2. The y-coordinate is negative square root of 2 over 2 from your unit circle. So tangent would be y over x. Tangent is negative 1 at negative pi over 4. But if I want to represent that point at negative 3, 3, so suppose that point sits somewhere up here, okay? Well, I can do an angle of negative pi over 4, but instead of going 1, 2, 3 units in a positive direction, I can go 1, 2, 3 units in a negative direction. So I can use theta equals negative pi over 4, but I'm going to need r to be negative. So r will be negative 3 square root of 2. So this point right here is the same as negative 3, 3. So there's my representation where r is negative, okay? I make an angle of negative pi over 4, but instead of going 1, 2, 3 units in a positive direction, if I make r negative, I'll go in the negative direction along that vector, 3 units, and I'll be at that point. So there's my case where r is negative. So that's how we convert from rectangular to polar and vice versa. All right, we're going to pause now.